Hello friends. Today we will take a look at another variant of a sensor designed for soil monitoring, which will help you take care of plants and will not let you forget to water them on time. This is a basic 3-in-1 version, which measures soil moisture as well as air temperature and humidity. There are also more advanced versions that measure up to 5 parameters. In addition to those listed, they also measure light level and soil fertility. As usual, we will check compatibility both with basic and with alternative smart home control systems. More details further on, but before we begin, as is customary, I ask you to like this video so that more people interested in the smart home topic can find it, and also subscribe to my channel if you have not done so before. Type of device: air and soil temperature and humidity sensor. Interface: Zigbee 3.0. Model: ZG-303Z. Measurement ranges: soil moisture from 0 to 100%. Measurement accuracy: 5%. Relative humidity: up to 99%. Declared accuracy: 3%. Operating temperature: from -10 to 50 degrees Celsius. Declared accuracy: 0.5 degrees. Resolution: 0.1 degrees. Power supply: 2 AAA batteries. Sensor dimensions: 150 by 30 by 18 millimeters. Soil probe dimensions: 82 by 18 by 2 millimeters. I would like to draw attention to the fact that in addition to the number of measured parameters, when choosing a sensor you also need to choose the supported version. In my case, this is the version simply labeled as Zigbee 3.0, which is intended only for alternative smart home control systems. The second version differs only in that it has support for the Tuya Smart ecosystem. In alternative systems, it is also supported, by the way. You simply pay a bit extra here for the presence of a license to work with the Tuya cloud. Functionally, there is no difference between them. The device is supplied in a small cardboard box, the front part of which was covered with stickers indicating 2 model variants of this sensor. Both, by the way, incorrect, and an indication of operation with the Tuya ecosystem. Although when ordering I chose the version without Tuya support, which I do not need. On the other side, the correct model is already indicated, ZG-303Z. The parameters I mentioned are duplicated here. The package includes only the sensor itself and a small manual. There are no batteries included. They need to be provided separately. The manual is provided in English and Chinese. It describes the main elements of the sensor, how to correctly install it in the soil, at a right angle, so that a small part of the probe remains above the surface, and the parameters are duplicated once again. The device has a classic, so to speak, design for sensors of this type. A long probe that is inserted into the soil and the sensor itself. In the center of the front part, there is a round button with a drop icon. This is not a touch button, but a physical one, intended for checking the connection and switching to pairing mode. It requires force to press. On the probe, conductive tracks are visible, thanks to which the measurement is performed. This is what probes of models without soil fertility measurement look like. They do not have additional contacts. The backside of the device, there is nothing interesting here. On the upper part of the sensor itself, the battery compartment cover is visible. As I already mentioned, for the device to operate, 2 standard AAA batteries are required, which, thanks to the contact on the cover, are connected in series, producing a voltage of 3 volts, like commonly used lithium coin cell batteries. Only in this case, there is higher capacity and lower sensitivity to cold. As I already said, I chose a model without Tuya support, but I still decided to check compatibility, especially since the sticker on the box said that the sensor was Tuya. For connection, as usual, I use a Zigbee thread gateway from MOS. As expected, no miracle happened. At the physical level, the gateway sees the sensor and correctly identifies its type, but at the logical, cloud, level, it does not connect it to the system due to the absence of Tuya certification. That is why this version is cheaper, although functionally it is completely identical to the version with Tuya support. Therefore, we move on to alternative control systems and, as usual, start with ZHA, the built-in home assistant integration for working with Zigbee devices. As a coordinator, let me remind you, I use a USB Zigbee stick with SkyConnect firmware. To switch to pairing mode, you need to press and hold the button on the sensor. Let me remind you, it is pressed quite tightly. until a red LED under it starts blinking. After that, it is detected by the system. In ZHA, apart from the battery charge level and the standard identification button, only 2 out of 3 parameters were detected. Soil moisture. It is currently equal to 0 since the sensor is lying on the table, and air temperature. I will install the sensor in a plant pot, according to the instructions, so that part of the probe remains above the surface. After some time following this, the moisture reading was updated. Here is an immediate benefit from the device. The plant really does need watering. All further actions I will carry out in ZG-303Z. As of the testing date, the current version is 2.7.2. As a coordinator, I am using a rather old network version based on CC2652P. Here, the sensor was also detected completely normally, with a correct image and model number. External converters are not required. Here we see extended information about the device. The correct model name is displayed, ZG-303Z, Zigbee model, one of the most common, TS0601. I will also clarify that the sensor is an end device. Let's take a look at the exposes page. There are far more entities here than we saw in ZHA. First comes a binary sensor, which will trigger when the lower soil moisture threshold is reached. It is configured right here. Next, data from the air and soil temperature and humidity sensors. For the latter, the data has not yet been updated. Next, the settings. Temperature scale, degrees Celsius or Fahrenheit. Then calibration of each sensor parameter, temperature, air humidity, and soil moisture. Then the polling interval from 5 to 3,600 seconds, with 30 set by default. Looking ahead, I will say that according to my observations, this is just the maximum frequency limit. If the parameters do not change, polling may be less frequent. Next comes the setting of that same lower soil moisture threshold, to which the binary sensor I already mentioned will react, and standard entities, battery charge level, and signal quality. These parameters, via Mosquito Broker and the MQTT integration, are passed into Home Assistant. They are divided into several blocks. The first contains calibration and setting of the lower soil moisture threshold, polling interval setting, and the scale. Then comes the block of sensor data. Soil moisture is not there yet. It will appear a bit later. Along with them, a sensor for dry soil notification. Then, in the configuration block, calibration of air parameters, and at the very bottom, the charge level. After a few minutes, the soil moisture data was updated. Since the first measurement during ZHA testing, the value has slightly increased. It is time to water the plant. I have already tested similar sensors and often, during watering, their readings immediately jumped to 100%, then after some time, just as rapidly dropped by several tens of percent. Here the behavior is similar, though not to 100, but to 76%. But the point is that the sensor definitely reacts to watering. Since I do not have a reference soil sensor, I can conduct a comparative test only based on air parameter data. As usual, I will compare it with a proven sensor from Xiaomi, which I placed nearby for the duration of this test. Here are the current data, the review subject on the left, Xiaomi on the right. About an hour has passed since it was placed next to it. As we can see, the temperature data differs by less than 1 degree, while the humidity differs quite significantly. But this is not so important, especially considering the possibility of calibration as a trend. That is, how the sensor reacts to changes in air parameters over time. This is what I will be checking. The shown graphs were recorded over an interval of 15 hours. At the top, Xiaomi, at the bottom, the review subject. Overall, I can conclude that both sensors react to changes in real temperature in the same way. The shape of the graphs is very similar. Xiaomi's data transmission frequency is higher. By the way, here it is clearly visible that the soil sensor polling frequency is definitely not 30 seconds as set by default, which confirms my theory that this is only a limit, not a strict parameter. Humidity graphs. Overall, their trend is also similar, but with some spikes on the Xiaomi side. Perhaps this is related to how its air intake was oriented. But in general, I can conclude that the review subject reacts adequately to changes in humidity. And this is the soil moisture graph. I have nothing to compare it with. On the left, a peak during watering, then, as I expected, a sharp drop of about 20%, then a more or less flat line with some movements up and down. Since I trust the data from the Xiaomi sensor more, especially as it is confirmed by data from other sensors located here, I adjust the air parameters on the review subject using calibration. Now the parameters are almost identical, and over time after this calibration, they continue to remain so. As I said, the numbers are not as important as the correct reaction of the sensor, and the values can be adjusted. Overall, after conducting this testing, I have formed a good impression of this sensor. It correctly reacts to changes in air parameters and watering and can remind you that it is time to pay attention to the plant. When choosing a device model, pay attention to its support, depending on which system you plan to use it in. If soil moisture alone and air parameters are not enough for you, pay attention to versions with a light sensor and soil fertility measurement. That's all. I hope this video was interesting and useful for you. I would appreciate your likes. They help promote the video on YouTube. If you are not yet subscribed to my channel, now is the time to do so right now. In the description under the video, you will find all the necessary links to stores where you can purchase this sensor, as well as to my social networks, Telegram channels, and a group for discussing smart home topics. Join in, it will be interesting. Thank you for your attention. See you next time, and peace to everyone.